Okay, today's lesson is 6.3, solving linear systems using inverses and Cramer's rule. Now you have done both of these before, so I'm going to talk rather quickly. You can slow me down with your settings if I'm talking too fast. So start off with an invertible square linear system. Don't worry about it. We've got a matrix equation here. You know it's a matrix equation because all of these are capital letters. So we have A is a coefficient matrix, generally is what we're going to talk about. X is your variable matrix, and B is your constant matrix. And to solve that and to get that by itself, to get the variable matrix by itself, we multiply by the inverse of A. And you have to remember that matrix multiplication is not commutative, which means the order that you multiply matters. So when you start off with this equation, to solve it, it has to be in this order. So the variable matrix equals the inverse matrix times the inverse of the coefficient matrix times the constant matrix. So let me do an example. I'm going to have those handy so that you can see how it follows that right there as I go through it. So to start off with, use an inverse matrix to solve the system of equations if possible. Okay, so I have a system and I'm going to write an equation, a matrix equation like this right here. So I start off with my coefficient matrix, and my coefficient matrix, the first column, as I've mentioned to you before, is going to be the x coefficients, 6 and negative 4. The next column is going to be the y coefficients, 1 and negative 5. Then I'm going to multiply by the variable matrix. My variables are x and y, and that's going to be equal to the constants, which are negative 8 and negative 12. Okay, so that's my setup. Then to solve it, I know the variable equals the inverse of the coefficients times the constant. So I'm going to write that step. Variable equals the inverse of the coefficients times the constants. And I find that when people don't write this step, y'all, they mess it up because they forget this little symbol right here. They think they can do it without it. But that little symbol, that's what you worked on in the previous lesson, finding the inverse of a 2 by 2. So how do we do that? We're going to have, you have to take 1 over the determinant, which is downhill minus uphill. And then when you create that new matrix, you switch the main diagonals. So I'm going to have, instead of 6 in the top left, I'm going to have negative 5 and a 6 in the bottom right. And then I negate the other diagonal. So instead of negative 4, I will have positive 4. And instead of positive 1, I will have negative 1. And then I'm going to multiply that by the constants. Now, when you do that, y'all, it's a lot easier if you will multiply these two first before you distribute this. So that's what I'm going to do. This first one is a 2 by 2. This is a 2 by 1. These two inside numbers are the same, which means the outside numbers are going to be the dimensions of my new matrix. So on my next step, I'm going to have 1 over negative 26, and then I'm going to have a 2 by 2. I didn't want to tell you what that was, but that doesn't really matter. 52 and negative 104 is what you get when you multiply these two. Okay, and you did that. You know how to do those things. So then you distribute your determinant value out front. So you're going to end up with negative 2 and positive 4. And your answer is written as an ordered pair. It should be in Delta Math. I'm not sure. You've got to pay attention to the directions. But when you're solving a system, it's an ordered pair. All right. To make it faster, this is the same thing. You can look at the filled out notes on the calendar if you want to see that one. All right. So the next thing I'm going to do is go talk about Cramer's rule. Okay, Cramer's rule is another method for solving square systems. Okay, and they have to be square because in Cramer's rule, we're going to use the determinants instead of row reduction, which is what you did on Monday and Tuesday and Wednesday, or inverse matrices, what I just showed you. So if I had a standard system of equations, it would look something like that. Okay, that's a standard system of equations in two variables. Then x is equal to the determinant of x over the determinant of the coefficients, and y is equal to the determinant of y over the determinant of the coefficients. Okay, the determinant of the coefficients, okay, that's what we just, I was talking about the coefficient matrix. Well, if I were to find if I were to write that coefficient matrix and find the determinant of it, that's what we're saying. So our determinant of our coefficients is getting the coefficients of this system right here. And my coefficients are A, B, D, and E. First, A and D, B and E. Okay, now this is the key. This is what you have to remember. To find the determinant of X, which is what I have up here, okay, then what you're going to do is in this determinant, D of X, or the determinant of X, you're going to take the constants from our system and replace them in your X coefficients. So instead of having A and D, I have C and F. The B and E stay the same. Now to go to D of Y, okay, then I'm going to take the my first column of X coefficient stays the same, and now I'm going to take the constants and replace them in the Y coefficients. And then you just, oopsie, calculate it as normal, okay, because you know how to calculate determinants. So let's go do a 2 by 2 real quick, and a 3 by 3, and then we're going to be done. All right, use Cramer's rule to find the solution of each system of linear equations if a unique solution exists. So on this first one, we're going to go find the determinant of each of these, and I'll tell you in Delta Math you have to find all of these. So this first one is the determinant of my coefficients. Okay, my X coefficients, 2 and 5. My Y coefficients are -1 and -3. If I do a downhill minus an uphill, then I'm going to get -1. Okay, determinant of my X means that my X coefficients are replaced with the constants of 4 and -6. The Y coefficients stay the same. Calculate downhill minus uphill, and you get -18. The determinant of Y, my X coefficients stay the same. My Y coefficients are replaced with the constants. We calculate that, we get -32. Okay, and then the step is to put it together. X is going to equal to the determinant of X over determinant of X, which is -18, over the determinant of your coefficient, which is -1. So X equals 18. Y equals, what does Y equal? Y equals the determinant of Y, which is -32, over -1, which is going to be 32. So my answer is 18, 32. Okay, this other one, I'm going to skip 3B and go to 3C, okay, because when you do that, when I set up my determinant of my coefficients, I have my X coefficients are 12 and 4, my Y coefficients are 9 and -3, and when you calculate downhill minus uphill, you get 0. So when you calculate, if you ever calculate the determinant of the coefficients, y'all, doesn't matter about the other ones, the coefficients, that's why you always want to start with that one. If you get a 0, then that tells you it can't be solved with Cramer's rule, and there is no unique solution, okay? I can look at this and tell you those lines are parallel, so they're never going to intersect, but you can find that with another method. You just can't continue it with Cramer's rule. All right, one last one I want to do. To show you with a 3 by 3, and I'm going to show you on in class calc to remind you how to do a determinant in case you don't know. So we're doing Cramer's rule again. So the difference, I just did Cramer's rule with 2 variables. It was the determinant of X over the determinant of the coefficients. You just add another variable, you add Z to it, okay? And so that's kind of why I wanted to do this problem for you. So let me scroll down. Let's go right there. Okay, so the first one is going to be the determinant of the coefficients. My X, -2, 3, and 1. My Y is 4, 1, and -3. And my Z coefficients are -1, 2, and 0. Now, actually, I'm going to leave it there. We'll come back and show you how to do all those. All right, so my determinant of X is going to be not that cat, so ignore that cat. But I replace the X coefficients, so that's why. And now instead of having -2, 3, and 1, I'm going to have my constants, which are -3, 6, and 1. And the rest of it stays the same. Ignore the cat. Okay, then I have the determinant of Y. So my X coefficients stay the same. My Y coefficients are replaced with the constant, and then I have my Z's. And then I have d of z. X coefficients stay the same, y coefficients stay the same, and the z coefficients are replaced with your constants. Okay, then you do the same thing, but we have to go calculate. So I want to show you this real quick. So to calculate, all right, I did this already to show you all the numbers, but really what I want to tell you, and you know what, I should just clear all this because I can do that and show you. When you want to do one, so I'm going to do the determinant of the constants. In in class calc, you go to the matrix menu and you pick a matrix, doesn't matter what letter. You add rows and columns. I have a 3 by 3, and I'm going to go put in -2, 4, -1, 3, 1, 2, 1, -3, and 0. Okay? And then to get the determinant, you can either type the letters DET or you can hit that button and then hit A, and we know that our determinant is 6. So that's all you got to do each time. You will have to do that because in Delta Math, you have to give each of these determinants. But that saves you a lot of time than what you've done before when you did determinants by hand, but you needed to know that for cross product of vectors in the future. Okay, so determinant of the constant, we got 6. The determinant of x is 9, determinant of y is 1, and the determinant of z is 4. So remember, x equals d of x, which is 9, over d of c, which is 6. That becomes 3/2. Y is going to be d of y over d of c. So that's 1/6. Z is d of z over d of c, and that equals 2/3. So our final answer, written in an order triple, because that's the way it is 3/2, 1/6, 2/3. And that's all we have to solving linear systems using inverses and Cramer's rule. If you have any questions, please don't hesitate to come see us or email us. Thank you so much, and y'all have a great day.